address of your good cutting.
Good afternoon, students. Am I audible? Am I audible? Any one of you unmute yourself and tell me whether am I audible or not.
Yes, sir, audio.
So in my last class, I think I was discussing something about the forms and structures and textures of igneous rocks. So I will continue it and I'll wrap it today itself. Okay. So for first internals, all the things that will be covered until Saturday will be there for your examinations, internals. Okay. By tomorrow, I'm going to upload some of the notes, other notes and the PPTs to the Google Classroom. Has everybody joined the Google Classroom? Because the question paper will be uploaded in the Google Classroom itself. Okay, make sure that every one of you will join the respective classrooms. A section students to A section and B section students to B section. Okay, and today there was some issue with the problem with the power in near our house. The entire locality, the power was not there, so I was not able to take the class. So once the current just came now at 1 o'clock, the current just came, power just came, so I started the class today. Okay, so in my last class, I think I was discussing something about the forms and structures of the igneous rocks. So we shall wrap it today. Yeah. So is the PPT visible? Okay. So today we shall continue our discussion on the structures of the igneous rocks. Now, what are structures of igneous rocks? So you have seen the textures, is it not? You have seen the textures of the porphyritic texture, the pegmatitic texture, the vein-like texture, the uneven grain size, the even grain size, everything like that. In my last class, I think we have seen all these things. Is it not? The euhedral, subhedral, shape or size of the grains, all these things. Okay, this is because of the cooling behavior of the magma. Okay, how the magma cools, what is the rate of cooling of the magma, all these things are dependent for the formation of the structures. Okay, similarly for textures also, for the formation of texture also, the cooling behavior of the magma plays a very important role. Even for the cooling, for the structures to be formed, the cooling behavior of the magma plays a very important role. Okay, similarly structures, now we can see the structures that are developed in the igneous rocks during the formation time of cooling. Okay, there are two inherent features. One is the features that are inherent to the rock during the formation of itself. Okay, so for example, there are certain things that are inherent with the rock. Okay, for human beings also there are certain things which are inherent. Okay, as time develops we will develop some of the other features also. Similarly, the rocks also has got two types of features. One is the features that are inherent to the rock during the time of formation itself. Okay, whenever the rock is being formed, there are certain features that are formed during its formation itself, and there are certain other features which are formed after the formation of the rock. Clear? So that may be classified into two types. One is intrusive and the extrusive rocks. Okay, so the main classification for the igneous rocks are the intrusive igneous rocks and the extrusive igneous rocks. You have to pay very kind attention here, because they will ask for the classification of igneous rocks. You have to write all these things. If they ask for 15 marks, if they ask for 15 marks or 20 marks in the annual examination paper, then if they ask for classification of igneous rocks, you have to write the classification based on depth, that is plutonic, hypobasal and volcanic, the textural classification, and also classification based on the mode of formation, that is intrusive and the extrusive. Okay, so now what are intrusive igneous rocks and what are extrusive igneous rock structures? So intrusive rock structures means these structures are formed below the earth surface. Okay, it is not formed on the surface of the earth. Okay, but it is formed in the interior part of the earth itself. in the interior part of the earth itself, these structural features can be seen. Okay, now what happens is, if the pressure and temperature is present within the magma, if certain amount of pressure and temperature is present within the magma, then what happens is the magma will come out till the pressure and temperature is present within them. Okay, now during its course of journey from the core to the mantle to the crust, somewhere the pressure and temperature automatically goes down, is it not? Now for example, if we quote, for 1 liter of petrol, your vehicle may go for around 50 kilometers on average or 60 kilometers on average, is it not? It will never reach beyond the given mileage, is it not? Whatever the vehicle it may be, I'm taking on average scale. Okay, on average we are speaking here. Okay, so similarly what happens is, if in any rock type, what happens is, if in any magma, the magma has got enough amount of pressure and temperature within them, if it has got enough amount of pressure and temperature within them, then the magma will erupt outside, it will come outside the earth's crust. Okay, if it has got enough amount of pressure and temperature within them. Otherwise, if there is no enough amount of pressure and temperature within them, then what happens is, the magma has not got the capacity to come or erupt outside the earth surface, but it will be found within the earth surface itself in the form of injections or vein like structures. Okay, so if any time, if the magma is subjected to cool down and solidify in the interior part of the earth itself, not on the continental crust but on the oceanic crust or the upper mantle, lower mantle, or any parts anywhere, then such igneous rocks are called as intrusive igneous rocks. Clear? Which means to say, see, this magma, what happens is, if it has got enough amount of pressure and temperature to erupt outside, then it forms extrusive igneous rocks, because it has come outside the earth surface, it has come outside the earth surface. But if in any time the magma has not got sufficient amount of pressure and temperature, see, once the magma is moving, okay, it moves, it travels until it has got enough amount of pressure and temperature within them. Enough amount of pressure and temperature is present within them, the magma will certainly move. But in any point of time, the magma has not got enough amount of pressure and temperature within them, then what happens is, it will cool down, it will solidify in the interior part of the earth itself, it will not erupt outside. Okay, if it erupts outside, it becomes volcano. Okay, but now every now and then you cannot find a volcano. Okay, so such times what happens is, it will be formed in the interior part of the earth itself in the form of veins, injections, parallel like structures, everything like that. Okay, so such types are usually called as a intrusive igneous rocks. Okay, now we shall see which are the intrusive igneous rocks here. You can see here, these are the magma which are different types which are flown on the surface in the interior part of the earth itself. This is not on the surface, but it is found in the interior part of the earth itself. Okay, we can see some here, it has moved in the form of the injections. These are the different rock types, different colors are the different rock types. Okay, sometimes you can see it has formed in a very huge mass of igneous intrusion, it has formed in form of injections, it has moved parallel, it has moved perpendicular to the country rock. Okay, so these are the rocks, any rock that has moved perpendicularly, it has moved parallel to the rock. Okay, it has formed inverted saucer like structures, all these things. Okay, so these are the different features, like your sill, your dike, stock or pluton, batholith, lopolith, and the laccoliths. Okay, so these are the facholiths, and there are certain ones which are formed usually the intrusive igneous bodies. Okay, so these are the ones which are usually formed in the intrusive igneous bodies. Okay, so here you can see different types, how the igneous relations are being formed here. You can see here a batholith, a huge granite mass, okay, which has been uplifted. So this is lava flow, this is flown parallel to the, this is one rock, this has moved parallel itself, which is called as sills. If it is moves perpendicular to the country rock, see, these are the rocks, if any movement takes place perpendicular to the existing rock, country rock means the existing rock. Okay, so here you can see it has moved perpendicular to the existing rock. Such ones are called as dikes. Okay, here you can see it has moved parallel to the existing rock. This is one existing rock. Here the magma has moved parallel to the existing rock. Such ones are called as sills. Okay, so you can see the inverted funnel like structure which is called laccolith. Okay, so these are the different field relations of the igneous rocks. Okay, so there are two types. In intrusive igneous body, there are two types. One is concordant intrusion and another one is discordant intrusion. Okay, concordant intrusion means these are the intrusions which run parallel to the country rock. See here you can see this sill, the laccolith, even the lopolith. The one more feature. Okay, the sill, the laccolith and the lopolith always moves parallel to the existing rock itself. It never moves perpendicularly. Okay, in any time or in any case, if any movement of the magma takes place parallel to the existing rock, you can see here it has moved parallel to the existing rock. So this is the existing rock, so it has moved parallelly itself. Okay, so this is existing rock, it has moved parallelly. So such features are called as a concordant bodies. Concordant igneous bodies or concordant igneous intrusions. They may ask for 5 marks also. Write a note on concordant igneous intrusions in the examination. Okay, then you have to write sills, laccolith and the lopoliths. Okay, if they ask for discordant bodies, what happens in discordant bodies is that the magma moves perpendicular to the country rock. Here you can see it has moved perpendicular, is it not? The batholith has moved perpendicular to the country rock. Even the dike has moved perpendicular to the country rock. Okay, here in Pluton, you can see stock or Pluton, it has moved perpendicular to the country rock, existing rock. So such features where the raw magma moves perpendicularly to the existing rock, then such features are called as a discordant igneous bodies. They always cut across the bedding planes. They always cut across the bedding layers or the country rocks. So now let us look at the concordant igneous intrusions, that is the laccolith intrusion. You can see laccolith intrusion means these intrusions are result in the uplift of the folding structures. You can see these are because of the upliftment of the magma. Because of certain pressure, the magma, what happens is it has moved here. So there is no enough amount of pressure and temperature that is sustained within the magma to erupt outside. So what happens is it starts to solidify at this place itself. Then what happens is during the solidification, it assumes an inverted funnel like structure, inverted saucer like structure. You have seen the saucers, is it not? The tea saucers which usually the people give for the in the homes, okay, for the teas. So if any time what happens is if the magma assumes the inverted saucer like structure, if it assumes the inverted saucer like structure, then it assumes the form of laccolith. Okay, so what happens is these are the concordant types of intrusions which occur between parallel layers of the rock at a very shallow depths. The pressure of the injecting magma is high enough to deform the overlying strata. It is high enough to deform the upper layer, not to come outside the earth crust. Okay, it is only sufficient enough, the pressure is only sufficient to increase the or deform the structure of the upper layer. Okay, so what happens is the lower layer pressure of the overlying strata allows the magma to doom up. Okay, the pressure of the magma is very high, the pressure of the overlying layer of the rock is very low. What happens is that's why it assumes a inverted structure. You can see here, okay, the pressure of this is very low, okay, the rock, but the pressure of the magma is very high. Clear? So when the pressure of the magma is very high, what happens is it is not very high to come outside, but it is high for this rock or this layer. Then what happens is it produces this one, it pushes the upper layer and to form a inverted saucer like structure. Okay, so this type of intrusions are usually called as a laccolith intrusions. Coming to the low polyth intrusions, what are low polyth intrusions? See, low polyth intrusions are the ones where it assumes a funnel like structure. This is a funnel like structure, is it not? Okay, so the magma pressure and temperature is not very high. So what happens is the pressure and the temperature is not so very high that it cannot come outside of the earth crust, but it has got some pressure to deform the lower layer, lower strata. Okay, so it has got the pressure to deform or come outside the earth's layer itself. Okay, in the interior part itself, not on the exterior part. Okay, such type of intrusions wherein it assumes that of a structure. Okay, so pressure of the injecting is very low and the pressure of the overlying rock is very high. See, this magma pressure is very low, the strata pressure is very high, so it can withstand the pressure exerted by the magma. That's why it becomes a inverted funnel or a funnel like structure. Okay, low polyth is nothing but a funnel like intrusion. Coming to the sill, what happens is, in sill what happens, the magma always flows in the form of parallel. It is not perpendicular. This is one rock type, this is one rock type. If the magma moves parallel between two rock types, then such a type of intrusion is usually called as a sill intrusion. Okay, coming to the batholith, so what happens is batholiths are the largest igneous intrusion, so large that their bottom is rarely exposed. So they are formed below, deep below the surface, where large magmas are cool and solidify, and also they are known to extend to unknown depths. Okay, very small example for your batholith and a stock. Okay, stock, for a very good example is your Shravan. Okay, the top of the Shravan is called as a stock. Okay, you can see the stock is very few kilometers. You can see the basement of the Shravan before you climb, it is very wide, is it not? So that stock is your Sidganga Betta in Tumkur. It's also a very good example for your stock. Sidganga batholith, it's also known to be a batholith only. Okay, but it is known to be a stock also. The Sidganga Betta, the Shravan are the very good examples for your stock features and the batholiths. Okay, they are very huge igneous granitic mass intrusions which have exposed on the top of the earth. Okay, the magma has not come out, but it has solidified, or a huge mass of magma has just come up on the earth's surface, and the pressure was so much that it has uplifted the surface of the earth in that way. Okay, coming to the discordant igneous intrusions. Now, what are discordant igneous intrusions? See, discordant igneous intrusions are the ones where it always moves perpendicular to the pre-existing rock, forming fractures, or it moves vein like structures, or in the form of injections or anything like that. Okay, so in the form of injections, or if it moves in the form of the veins, then such type of intrusions are usually called as discordant igneous intrusions. Okay, so what happens is, the magma, there are many openings that are available in the earth's crust, in the interior part of the earth. There are small vein like, or the openings that are available, through which pores or fractures, through which the magma movement can take place very easily. Okay, so the magma movement can take place very easily through that kind of structures. So that place where the openings are available for the magma to move very easily are called as a intrusive igneous bodies, and one such type is a dike. You can see these dikes are the ones which cut across or move perpendicular to the pre-existing rock bodies in the form of injections. Okay, so then coming to the pillow structures are the ones when the lava is comparatively viscous and less mobile. Okay, so if it is high viscous and high mobility, high viscous means Viscosity means in Kannada they call jigututana. Okay, for example, if we drop curds and water, okay, water is less viscous, hence it can travel to very long distances, whereas curd is high viscous, so it cannot travel to very long distances. I think you got my point. Okay, viscosity means something called jigututana. Okay, so between acidic magma and basic magma, what happens is, in acidic magma it contains more amount of silicon and magnesium, aluminium, silicon and aluminium. Okay, so that's why the viscosity is very less, hence it can move to very far distances. Whereas in basic magma it comprises more of iron, magnesium, where it comprises of more of iron and magnesium in them, so viscosity is very high, so it cannot move to very long distances. Okay, so what happens is, it is formed, this pillow structure is formed under the water, under the water itself, under the sea water, when it forms like bulb like structure. You can see initially there were some incandescent bulbs that were being present in the homes, 100 watts bulb, 50 watts, 40 watts, 60 watts bulbs. Okay, magma erupts in the form of bulb like structure, which is called as a pillow structure. Even to today, in a place called Maradihalli. Maradihalli is a place very close to Chitradurga, I think 5 kilometers from Chitradurga. Okay, there is a place called Maradihalli where this pillow lava can be seen. Okay, so which suggests that our entire Shumaga or the entire southern India was under ocean. So what we say was, the earth was when during the formation of the earth, after the before the continental drift theory, our India was at the southern plate. India and Australia were together with the southernmost place near Antarctica. At the southern pole itself, Antarctica, this Australia and India were present. During the continental drift theory, what happened was, this it started to move towards the northern hemisphere. We started to move the earth, the part of the Indian plate started to move towards the northern plate, northern hemisphere. Okay, so at that time, when it was present in the southern hemisphere, at the when the earth when the initial days of the earth, the part of this southern India, this part of southern India, especially the Chitraga and other places, this Chitraga, that place was underwater. Okay, so that underwater, this pillow structure or the pillow magma was being formed, which is even to today present in Maradihalli near Chitradurga. Okay, so this suggests that that the Indian plate was at the southern hemisphere and also beneath the oceans, beneath the water, this place was being present. Okay, after the movement of the earth, the plate, when it moved towards the northern hemisphere itself, it started to expose to the land. Okay, so coming to the flow structure, flow structures are formed by continuous and smoothly moving lava on a slopy surface of the earth. So these structures are formed when the magma is less viscous and more mobile. So pillow structures are formed when the magma is more viscous and less mobile. But these flow structures are formed when the magma is less viscous and more mobile. You can see the flow structure of the magma. These are the very beautiful pictures of the Hawaiian magma, which causes the flow structure to be formed. There are two types of the ones. One is a blocky lava and another one is a ropey lava. Okay, so blocky lava is a one wherein the magma is very less mobile, that is more viscous and has a rough and irregular surfaces, and it has got vesicles in them. Okay, it forms block like structures. Okay, but when it cools down, it results in the angular chunky texture, which causes the magma to form a spike like structures on top of them. Okay, there are certain spikes, mul ತರ ಆಗಿರುತ್ತೆ ಆ magma ಮೇಲೆ. Okay, so when people try to walk on them, that needles always injects to their feet. People start to shout, yell. Okay, people start to yell. Okay, so that's why it is called as a AA lava. Okay, A lava and the O lava. So this is your ropey lava where it is more mobile, that is less viscous, and it has got formed a rope-like structures. You can see the magma has called formed as a rope-like structures. In Japanese term, they call it as a fahohi lava, fahohi texture, which means to say it is formed in the form of a ropes. Okay, so these pyroclasts are the ones wherein are formed from a very huge explosion. Before the eruption of the magma, there are huge eruptions that are being usually found. Okay, which are called as a volcanic fragments. They are the airborne bomb like structures, bombs, volcanic bombs, usually before the explosion of the magma. Okay, so they are called as a pyroclastic rocks or the pyroclastic textures. Okay, you can see this is a volcanic bomb. Before the explosion of the volcano, there are certain volcano bombs which comes out, the pyroclasts which comes out from the earth's crust. Okay, so which comprise of head and tail. Okay, so those are called as a volcanic textures. Okay, next is your orbicular structures which are formed by the orbicular like structures. You can see the orbicular like natures. Okay, so spherulitic ones means there are very small needles which are found within the country rock. Okay, so vesicular structures means it comprises of vesicles, that is here openings, small tiny openings which are being present within the rock. Okay, so those tiny openings which are usually found on the country rocks. Okay, they contain the gas materials within them. Okay, whenever the gaseous materials escapes out, okay, leaving behind the vesicles are the tiny openings. So these tiny openings are usually called as a vesicles or a vesicular structures. Okay, columnar ones you can see in the St. Mary's Island, which is resultant of the cooling behavior of the magma itself. This is also one of the structure. I think with this we have completed the forms of the igneous rocks, structure and textures of the igneous rocks. If you have got any questions, you can ask me at any point of time. So these are very important ones for the examinations and other points. Okay, so with this I'm going to stop my discussion here. If you have got any questions, we can continue discuss in the next class. Drop in your names and the USNs for the attendance. Okay, thank you.